problem with renewable energy is the lack of continuous supply. Solar power only when it's sunny, wind power only when it's windy, and wave power when the sea's not too rough. I'm Russell Beard and I've come to South Spain to visit Gemma Solar, the first solar tower power station that can produce electricity 24 hours a day. But in order to get a real sense of the scale of this place, I need to get a little bit higher. Samuel! Wow, my heart is in my mouth a little bit, but it's incredible. And I can't believe I'm flying this plane. So Sam just spotted the tower up ahead, so he said just point at the tower and carry on. Okay, here's Gemma Solar. You can see it just below us now. Thousands of these heliostats, these revolving mirrors. It's just amazing. Feels like we're looking into the future. Photovoltaic is like one of the fastest growing energy sources in the world at the moment, but these aren't photovoltaics, are they?
No, not at all. They are not photovoltaics at all.
So these
Those
are
just glass, are mirrors, and they are reflecting the light on top of the tower.
The reflected sunlight from the 2,650 heliostats combined can generate enough electricity to power 25,000 homes, but only if they're all pointing in exactly the right spot.
Santiago's brought along one of these miniature parabolic mirrors, which I guess is almost like a perfect scale model of your solar tower.
Yes, I mean the tower looks like in the middle of a circle of heliostats, and every heliostat is like, taking a different angle to reflect the light on top of the tower and then to concentrate all the energy on a single spot.
So let me try.
It's going.
Oh wow, you can see it catching fire. It's so sensitive, like one tiny degree out and it stops burning. I mean, this must be the challenge that you're facing.
Exactly, I mean, exactly what we have to be doing. I mean, we have to be very precise in moving the heliostats in the right position to concentrate the light there.
Sunlight is reflected from each heliostat onto a central receiver at the top of the tower. Sodium and potassium nitrate salts are pumped from the cold salts tank up to the receiver, where they absorb the concentrated solar thermal energy, reaching temperatures of up to 565 degrees. The heated salts are then pumped down to the hot salts tank, where they can be stored in a molten state or used to generate electricity via the heat engine.
This is the hot molten salt tank that contains the molten salts at 565 degrees. This is like a big battery, but it's a thermal battery. It's not an electrical battery. In fact, the energy which is accumulated here is enough to continue operating the turbine for 15 hours at full speed.
So this is what distinguishes this place from other solar tower generators around the world. It's actually that storage.
Exactly.
Being able to store energy this way means that solar power can, for the first time, be provided 24 hours a day, not just when the sun's shining.
This is the vessel in which the water becomes steam. Inside you have water at maybe 500 degrees centigrade and already 100 bars of pressure.
This is incredible. So what Santiago's telling us is, despite how futuristic this all looks, the actual business end where they create the electricity is much the same as any other coal-fired or even nuclear power plant. So see, it's a steam-driven power plant. Wow. Wow, this is what I'm talking about. Now this looks like a power station.
And it is.
This technology has been around for hundreds of years, yeah?
Yep.
And so it's really out there, it's the only sci-fi part of this building. By the time the power comes down from the molten salts, we're talking about good old-fashioned steam turbines, and that's what we can hear now. And you can even see it coming out of the little chimney at the top.
We are going to be reducing our costs, but also due to the fact that the oil prices are going up will make it impossible to burn gas to produce electricity. And then our plants will continue to be delivering cheap and clean energy to our children, let's say.